Displacement and velocity is a communication question C1. An object is moving along a straight line. Its distance s of t is shown in the figure. When is the object moving in positive direction? When is velocity 0? And draw the motion of the object along a horizontal line. So these questions are related and let's answer them one by one. So here we have a graph which represents displacement of an object with time. So S is the displacement. We see from the initial position, well, this part, ignore this part. We'll consider the time t greater than equal to 0, right? So we'll start from here, that's our initial point. And as the time increases, we see that the displacement increases, and that's approximately, we can say this is approximately 32 units, okay? So writing 32 since we have to draw the motion of the object along horizontal line, right? At this point, it seems that the object turns, right? From 0 to time 2. What we observe is that the distance is increasing. At 2, the object turns and distance starts decreasing. Do you see that? And till 6, it comes back to its original position. Do you see that? So the displacement from the original position is 0. So at 6, the object comes back to the original position and then turns back and moves on. So that is how this displacement curve is being shown here. Now let's try to answer the questions. When is the object moving in positive direction? So object moves in positive direction when displacement increases. So whenever displacement is increasing, right? Then the object is moving in positive direction. Then we say positive direction, okay? Important thing to note here is positive direction, not positive value. You can see that from 0 to 2 it is, so from 0 to 2 the object is moving in positive direction since the displacement is increasing during this period. Now displacement is positive all throughout except for these 2 points, but that does not mean it is increasing, so don't get confused about that. Then it starts increasing after 6. So it starts increasing after 6. So we can say 6 to whatever, right? So we'll just write infinity here for the time being, right? So these are the 2 intervals when the object is moving in positive direction, okay? We are not asking when is displacement positive. We are asking when is object moving in positive direction. Now movement relates to rate of change. So you'll observe that during this path, if you make a tangent at any point, then it has a positive slope. Do you see that? Here also it has a positive slope. So the relation here is that the velocity should be greater than 0. So whenever the object is moving in positive direction, then rate of change of displacement with time has to be greater than 0. So that is the key issue, and that means if you draw a tangent on your curve, it has to be with positive slope, right? So that is how, with the help of velocity, we'll relate all these questions. When is velocity 0? Now velocity is rate of change of displacement, right? So what is velocity? Velocity is ds over dt, right? So ds over dt is tangent or a slope. It represents slope or instantaneous rate of change, correct? So instantaneous rate of change 0 is when you have a horizontal line. Do you see that? So that happens at t equals to 2 and at t equals to 6. So when is velocity 0? So the answer is t equals to 2 and at t equals to 6. Okay? Now the third question here is draw the motion of the object along the horizontal distance line. So what we're trying to do here is to understand this, that actually this motion is taking place along a horizontal line. And let's say this is our starting point, 0, right? Now what happens here, in first 2 seconds, so the object moves from here, we say, let's draw here. So object moves and covers a distance of 32 meters. Do you see at this point? and at that point it turns, right, and comes back to the initial position. That means it comes back to, these are overlapping lines, but just for clarity I'm showing it downwards, right, comes back here, and this is when t equals to 6. At this point again it turns and moves along. So that is how we can actually show displacement along timeline. Do you see that? So the time is going by, and what happens really at, this is the location at t equals to 0. So at t equals to 0, s is also 0. So that is the starting point. Say t equals to 0, s equals to 0. Now here what really happens is time at this position is 2 for us, 2, and displacement is 32. Correct? And we also found this is the turning point. Well, at every turning point the velocity is going to be 0, right? The object turns, right? So that is the turn. At this time, that is, it goes back to the initial position, and the time is 6. So t is 6, and the displacement s is again 0. So the object returns to its initial position. So this is the forward direction, you can say, the positive direction which we meant, right? Then again from here the object moves in the positive directions, right? So that is how we can draw this timeline. At times they may tell you draw it when t equals to 8, for example. So if you are drawing it till 8, then you will just extend this line and say, well, now this position represents t equals to 8, for example, and at 8 you look for a point, and then you say, well, at 8 this is my point, and that is 35. So s equals to 35. All units, time is in seconds and displacement is in meters in this case. Mind it, the real motion is taking like this on a straight line. So the object really moves first it moves like this in the straight line, right? And then returns back and then again moves forward like this. So that is the actual movement, which I've kind of split and shown you here with the help of a horizontal distance line. It's a very clear-cut way of understanding what's really happening, right? So this can be shown in a displacement time graph. What you can also do is now show it in a velocity time graph. That means you can, so rate of change is positive here, so you'll go positive, then 0 there, right? And then decreases and then goes to positive. So try to make a velocity time graph from here as an added exercise. That will be good. But in any case, let's get back to this problem and understand it. It shows displacement time graph and tells us that the object is moving in the positive direction when the displacement is increasing, and also during that time velocity is greater than 0. When velocity is 0, at that time it is a turning point. It is a point when object is at standstill, object is not moving. Now if the velocity is negative, then object is approaching, displacement is decreasing, right? Or it is negative direction, right? So that is what we've learned from here. Another thing is we've learned how to draw or how to show the motion of an object along a horizontal line. So important things to show here is the turning points, time it takes to be there, and the displacement which is made during that duration. Now we'll back up these kinds of communication questions with numerical problems so that you have very clear understanding. So we have a combination here. So while it is not with each question, but kind of, which shows you the numerical calculations by which you will understand these concepts better. So go through question number 1 and then move on with rest of the questions in this set of videos. I hope you enjoy and understand higher order derivatives and the relation between displacement, velocity and acceleration by the end of these videos. Thank you and all the best.